Hey, what's up, guys? Today we're going to be talking about how to determine range without a rangefinder. So the reason this is important is because though laser rangefinders are a helpful tool, as things like night vision and thermals become more readily accessible, we need to be able to determine range without burning our position by shooting a laser that leads directly back to us. So in order to estimate range without a rangefinder, you're going to need an optic that utilizes miliradians or mils. And you've got a few different options for these. You can go with an LPVO that uses a mil reticle. On the left here, I've got a picture of the Trijicon VCOG, or known to the Marine Corps as the Squad Common Optic. Or you can get a magnifier for your red dot or holographic sight that has a mil reticle. In the middle here, I have a picture of the Primary Arms SLX 3x magnifier with the ACSS Pegasus ranging reticle, which is what I use in conjunction with an EOTech on the rifle that I compete with. Or you can even get binos that have a mil reticle inside of them. So if you're going to go with that LPVO option, or if you're just a dude who wants to be more capable with the gear he was issued, you need to understand the difference between a first and a second focal plane optic. The Trijicon VCOG here is an example of a first focal plane optic, meaning that the reticle itself gets bigger as you increase the magnification. And this is going to be super important when you're doing your range estimation so you can get an accurate mil value of your target. Alright, so let's talk about what those mils in your reticle actually mean. A circle consists of 360 degrees, or 6,400 miliradians. A miliradian is equal to 1 meter at 1,000 meters, or 10 centimeters, 3.94 inches at 100 meters. A miliradian, also referred to as a mil or an mrad, is a unit of angular measurement, and its value is determined by the range or distance at which it is being considered. So in order to determine range using mils, we're going to have to do some math. It's called the WeRM formula. You're going to need two things to solve this equation. You're going to need a known dimension, either in inches or meters, and you're going to need your observation in mils. So how many mils is that known dimension taking up in your optic? We actually have two separate equations that we use depending on whether your known dimension is in inches or if it's in meters. Alright, so let's talk about known dimensions for a second. Right here we've got the dimensions of your standard USPSA style silhouette target. You can absolutely take these dimensions, plug it into the formula we're about to go over, and accurately determine your range of the target. But for today's example, we're going to be using the military style Green Ivan targets. The reason for that is because these targets were created to depict the global average of a military aged man, that being 40 inches from belt line to top of the head and 19.5 inches from shoulder to shoulder. Alright, so this is our equation if our known dimension is in inches. So what we're going to do is take that known dimension, the number of inches, multiply that by 25.4. Then we're going to take that number and divide it by our observation in mils. So how many mils is that target taking up in your reticle? And that's going to give us our range in meters. And this is our equation if our known dimension is in meters. So for this example, we're going to say that we did a little bit of research on our enemy. We found out that they use the same model of truck for all of their technical vehicles. The dimensions on that truck is 5.6 meters wide. What we're going to do is take that known dimension at 5.6 meters, multiply that by 1,000, and then again we're going to divide that number by our observation in mils. So how many mils in our reticle does that truck take up? That's going to give us our range in meters. Alright, so time for a practical application exercise. In this problem, our known dimension is going to be in inches, and I left the equation up on the left hand side so you guys can follow along. So our known dimension here is going to be 19.5 inches, and as we measure our target with our optic from shoulder to shoulder, we observe that it's taking up 3.3 mils. So we're going to take that 19.5, multiply that by 25.4, that equals 495.3. Then we're going to take that number, 495.3, divide that by our 3.3 mils, and that equals 150 meters. Alright, so for our next exercise, we're going to be using that vertical measurement, so that 40 inches, and we'll measure our target from belt line to the top of the head, and we determine that he's taking up 5.1 mils. So we're going to take 40, multiply that by 25.4, that gives us 1016. And we're going to take 1016, divide that by our 5.1 mils, and that gives us 200 meters. Alright, so for our last exercise, our known dimension is going to be in meters. So here we've got our truck, and our known dimension is 5.6 meters. We observe that it's taking up 16 mils in our reticle, so we're going to take that 5.6 meters, multiply that by 1,000, that gives us 5,600. Now we're going to take 5,600, divide that by our 16 mils, that gives us 350 meters. Alright, so if you made it this far into the video, I'm going to leave you with this. It's a range estimation cheat sheet. So this is using those green Ivan targets or the global average of a military age man. So as we can see, we've got the vertical and the horizontal measurements. So if your target is taking up 10.16 mils vertically in your optic, you know it's at 100 meters. It's taking up 4.95 mils horizontally. Again, you know it's at 100 meters. So feel free to take a screenshot of this or copy it into your notes, because this is a tool that I use very often.